Okay, we're going to start Unit 2, Day 3, Absolute Value Inequalities. So you can see the objective there is to solve absolute value inequalities. So we have two important words that we need to always look for. Keyword is or. That occurs when we have these two inequalities. So if it's greater than or equal to or greater than, so think of that greater, that keyword is or. Okay? And then the keyword is and if it's these two inequalities. Less than or equal to, less than. Another way to kind of think about this, going back to the red ones here, see how these arrows are kind of pointing to the right? The keyword or has an R in it, so maybe that'll help as well. But the bottom line is you need to understand, is it or, is it and? All right, so here's our first example. So you can now see this is absolute value inequality. Before we did, and this was an equal sign, well, now it's an inequality. So we gotta figure out, what do we do? So similar to equations, we're gonna set up our two parts. Now, we have to have the absolute value part by itself, which it is. So we're gonna set the inside greater than 3, and then the opposites of the inside greater than 3. Okay, so that's how we set up our two parts. Now we need that key word. Because this guy is pointing to the right because it's greater than, or I'm sorry, just greater, the key word is or. Okay, it's greater than. All right, so the key word is or. So we're going to solve both of our inequalities, and then we're going to kind of combine our answer at the end. So let's solve the first one here. So add your 5 to both sides. Always important to show your work. And now we're going to divide by 2. So part of our answer is x is greater than 4. All right, let's get our second part. Distribute your negative all the way through. To get your x by itself, we're going to subtract 5. And divide by -2. Now, do you guys remember with inequalities, what happens when we divide by a negative? We have to reverse that inequality sign. So x is going to be less than 1. Okay? So whenever you multiply or divide by a negative number, you have to reverse that inequality. So you hopefully learned that in Algebra 1. All right, so let's think about this. We have over here, x is greater than 4, or x is less than 1. So if you're part of one of the groups, that's part of the solution set. So what we generally do now is graph our solution set. Okay? So what we're saying now is x can be greater than 4, so we would have an open circle and shade to the right, and that would continue. So there's the part that, you know, x is greater than 4, or x can be less than 1. Okay? So we have two parts of our solution. So the answers to the right of the 4, 5, 6, 7, 8, 9 are part of the solution. The answers to the left of 1, 0, -1, -2 are part of the solution. Now we're going to kind of write all that together in set builder notation. So x such that x is less than 1 or x is greater than 4. Okay? So that's how you kind of put everything together. I don't know if I'll be able to squeeze everything on here. But set up your two parts, solve in each case, and then kind of combine your answer. So it's either this or that. So that's how you use the keyword or. All right, let's look at the next example. Now this one gets a little more challenging. So we can't set up our two parts just yet because the absolute value part is not by itself. We have to do that first. So subtract the 5 from both sides. Divide both sides by -2. That gets your absolute value part by itself. Okay, you have to do that first. Now again, we divide by a negative here, so we have to reverse that inequality sign. Okay, so that leaves us with the absolute value of x plus 1 is less than or equal to 4. So now we can go ahead and set up our two parts. So we're going to say the inside is less than or equal to 4, and then the opposite of the inside is less than or equal to 4. Now the key word here, look at your inequality, is and. So very important that we understand how to get that key word. So it's going to be this and this, so it has to satisfy both of these conditions, as you will find out. All right, so let's solve both. So subtract your 1 here. Here we need to distribute the negative. Divide by negative 1. Again, you're dividing by negative, so you have to reverse that inequality. All right, so here's where we have to be careful. And this is why we graph our solution set. We need a number that is less than or equal to 3, and at the same time, greater than or equal to negative 5. So again, that's where the graph comes into play. So let's put our key values on here. Okay, so we need a number, think about that, is less than or equal to 3, and...
Brittany, please come to the office.
Sorry about that. And greater than or equal to negative 5. So what's going to happen is we're going to have a solid dot on 3 and shade to the left, and then a solid dot on negative 5 and shade to the right. Well, we need the overlapping regions there. So those are the solutions. It has to satisfy both conditions, this and that, okay? So when we combine those, if we're going to say x such that negative 5 is less than or equal to x is less than or equal to 3. Okay, let me clean that up a little. All right, so x such that negative 5 is less than or equal to x is less than or equal to 3. That will satisfy both conditions. We need that because of that keyword and. All right, let's look at example 3. All right, so we have the absolute value by itself. That's good. So we can set up our two parts. Okay, so we do the opposite of what's the inside for that second part. Okay, so there's your two parts. Now, what's our keyword? What do you think? Keyword is or. All right, so it's going to be this or that. Okay? All right, so once you set up your two parts, go ahead and solve. Get your x by itself. Divide by 2. So x is greater than or equal to negative 5. Or the second one, distribute the negative all the way through on that left side. Add your 1. Okay, now here again, we're going to divide by a negative 2. So you have to reverse that inequality sign. All right, so this one gets a little tricky because of the keyword or. So we need a number that is greater than or equal to negative 5 or less than or equal to 4. Okay, so if we combine them on our graph, okay, let's put the negative 5 here. All right, so because of the keyword or, we need a number that is greater than or equal to negative 5 or less than or equal to 4. Well, what happens is we end up shading the entire number line because it could be this or that. It's not an and statement. So we end up shading the entire number line. So that means x such that x is an element of all reals. In other words, everything works. Okay, everything works. Now let's think about this. Let's go back to the original problem. Let's use some of our common sense. So whatever we plug in for x, okay, plug in the value for x, multiply by 2, add the 1. When you take that absolute value, isn't it going to be positive? Worst case, 0. Isn't it always going to be greater than or equal to -9? So that's why every single number works, okay? All reals. You can pick any number and it's going to work. So with practice, you could have looked at this ahead of time and say, oh, it's all reals. Everything's going to work because it's always going to be greater than or equal to a negative number. Always. All right, last example. All right, so again, we got to get that absolute value part by itself. So we got to subtract the 2 first. Okay, and then we're going to multiply both sides by 4. That's the easiest way to do this one. So multiply both sides by 4. That gets you the absolute value by itself. Okay, so the absolute value of x minus 3 is less than -4. So now we can set up our 2 parts. So x minus 3 is less than -4. And then the opposite of x minus 3 is less than -4. So there's your 2 parts. The key word is going to be and. Okay? All right, solve both. We're going to add the 3. So we got x is less than -1. Here, distribute the negative all the way through on that left side. Subtract your 3. And divide by -1. So again, we're dividing by negative, so you got to reverse that inequality. So let me slide this back up. All right, so let's think about this. Because of the and statement, we need a number that is less than -1 and at the same time greater than 7. Can you think of a number less than -1 and greater than 7? Can you think of a number? Okay, so let's think about this. Here's -1. So I'm going to graph something here, but it's not going to be the final answer, just so you know. So we need a number that is less than -1 and at the same time greater than 7. It's not going to happen, is it? Okay? It will definitely not happen. So nothing works here. So the graph would just be empty. And your solution would be x such that, well, actually we don't need that. My mistake. When we have that, we would just say no solution, because nothing works. No solution. Nothing is going to work. Now, let's go back to the original problem. Well, we got to go to here, actually. Once you get the absolute value by itself. So let's think about this. Whatever we plug in for x, subtract the 3, take the absolute value, the worst case scenario, it's going to be 0 or positive, right? It will never be less than -4. That's why it's no solution. So with these absolute value inequalities, make sure it kind of makes sense at the end. Set up your 2 parts, okay? Don't forget to graph your solution set. And that completes Unit 2, Day 3.